So now let's look at functions and relations, and in particular let's look at the question of whether a relation is a function. So the first step is let's think about what a relation is. A relation is simply a pairing of two sets. So we have an input set and an output set, and all a relation is a pairing of members of the input set to the output set. Very broad. So now let's think about if we have a relation, how do we determine if it's a function? And here's the definition of a function. We say that a relation is a function if and if for every input value there exists exactly one output value. Since the inputs are often x's and the outputs are often y's, not all the time, but usually, then another way to say that is for every value of x, there's exactly one y. So for every x, there is exactly one y. And let's look at an example of that. So there's all kinds of different ways functions can be represented, but here's one way that they're often represented, and that is as a pairing. So let's look at this relationship. This relationship says that we pair 3 with 5, and 7 with 9, and 10 with -4, 8 with 100, and 2 with 15. And the question is this a function? You simply say for every value of x, is there exactly one y? So in other words, if I tell you x is 7, do you have any doubt about what y is? You don't. Y is 9. And if x is 8, then it's 100. So this would be yes, it is a function. Here's a different example. Let's see if this is a function or not. Here we have 3 is connected with 5, 7 with 9, 3 also with -4, 8 with 100, 2 with 15. If you notice that, if x is 3, you're not sure whether y is either 5 or -4. And in other words, for this x, there's actually two values of y. So this is not a function. And here's the third example. This one's a little more difficult. Here, for every x, is there exactly one y? Well, if you notice that for 3 x's, 3, 7, and 2, they all have the same y associated with it. But even so, for every x, there's exactly one y. There's a classic drawing, actually a set of 3 classic drawings that kind of illustrate this. Let this be the input, and this be the output. And the arrows represent a pairing. And we could give these numbers or not. So in other words, 3 is associated with 9, 2 with 8, and 10 with 16. In this particular case, every x has exactly one y, so this is a function. Here's a case where it's not a function. And this is what we saw in the last example, in the example before that was not a function. We had, if x is 3, then y could either be 9 or 5, and if x is 2, then y is 4. In this case, if x is 3, y can either be 9 or 5. So for every x, there is not exactly one y value. So this would be a case of not a function. And here's the third possibility. And the third possibility is that every x has a y, but some x's have the same y. Let's do 2, 4, and 6, 5, and 7. In this case, if you tell me what x is, I know what y is. And the fact that 4 and 6 have the same y doesn't affect the definition. If you look at what the definition of a function is, it simply says that for every x, there's exactly one y. If x is 4, there's exactly one y, 7. If x is 6, there's exactly one y, 7. Another common way that functions are defined are by tables. So let's say 1, 3, 5, and 7. Let's say 2, 5, 7, and 9. In other words, x is associated with 7 when x is 5, y is 7, when x is 3, y is 5. You simply say here, for every x, is there exactly one y? If the answer is yes, we say yes, this is a function. Here's a case where it's not true. 0, 2, 2, 5, 10, 15, 17, 19. In this case, x is equal to 2 is actually associated with 2 different y's, so this is not a function. And the third possibility, you see when you graph y equals x squared, minus 4 is 16, minus 2 is 4, 2 is 4, and 4 is 16. Even though minus 4 and 4 both have the same y value, for every x there is exactly one y value. So for this function, this relation right here, this is yes, this is a function. And that's how you determine if something's a function or not.